Okay, so now we have definitions for various types of logarithms. We have seen two families, decreasing and increasing family. We know where they come from. Well, we discussed they are just inverse functions of exponential functions. And we have seen the description of the families. The increasing family is denoted, it comes from using the base which is greater than 1, and decreasing family members, they have base which is less than 1. Base is always positive. So these things we have seen. Now let's talk about some commonly used bases. So base can be anything which is positive and not equal to 1, but there are certain typical bases that we use frequently. So let's just jot them down. So there are three main bases that we use often. So we have base 2, and then we use base 10 commonly, and base E. So these two things, they are commonly used in mathematics and science. And base 2 is frequent because of computer science, and because there we use binary systems, so obviously we feel the need of base 2 logarithms over there. So these three bases are we come across very frequently. So the first thing is how do we write them? So the nomenclature. Well, for base 2 it's pretty straightforward. We just write log x base 2, and base 10, again proper notation should be this, but since it's very commonly used, so we can also write like this. So this means we have to be certain whenever we are writing a logarithm without its base, when the base is hidden, that would mean the base is counted as 10. So this is one particular notation, and there is another one where base is E. So this is the formal way to write it, and then we tend to write it like this, ln x. So whenever we write ln x, that would mean the base is counted as E. So this ln n comes from natural. So let me point it out here. So these logs, the ones with base 10, they are called common logs. The function is called common log, and the one with base E, that function is called natural log. And we can also call this binary log, anyway, so this one is common log, and in case of common log we can just drop the base. We can just write it without base, and we understand that the bases will be counted as 10. And for the natural log we can again drop base, but instead of writing log we'll be writing ln. Right, and so there is another notation. So this notation is consistent, but some authors, they also write this thing as logx, but that can be confusing. So we have to be very clear when we are talking about natural log and when we are talking about common log. So that precision must be there. So we'll follow this notation, and this is a very common notation. Now let's take up some examples using these bases. So let's start with a very simple problem. Let's figure out what should be the value of log 1000 to the base 10, or let me just write it log 1000. So when I'm not specifying the base, then in that case that is going to be counted 10. So this just means that the base is 10, and I just want the answer for this. Well, we will be talking about certain properties which we will just deduce from the properties for exponentials. So that is one side, but here we just want to use the definition, because we have seen what do we mean when we write log x base b. When we say that log x base b is y, so that just means that is just another way of writing that b power y is x. So these two things, they are same. So I don't need to go anywhere else. So if I want to figure out what is the value of this thing, I will just say that this is y, and I will convert this thing into my exponential equation, where this just means 1000 is 10 power y. So we can keep this thing in mind, that this thing was input and this was output. Now the role has exchanged. Base remains base. This 10 was base for log here, and now this 10 is the base for exponential function here. So writing this is exactly same as writing this, which means, and this thing is nothing but 10's power 3 is 10's power y, and since bases are same on both sides, that just means y is 3. So which means that the value of this log 1000 base 10 is 3. Very easy. So we don't need any property for this, nothing is required. Just use the definition. Let's take another one. Let's say we want the value of log 4 base 2. And now I can't drop the base, because if I drop this base, then that is going to be counted as 10. But here I want to specify that I require base 2, so I have to write it. So let's say this value is y, and just convert it into exponential format. So this just means that 4 is equal to 2 power y, and 4 just means 2 square. So we see that the bases are same. So we can equate the powers, which gives us the value, y is 2. So this is a very important feature which students generally miss. They directly jump to properties, formulas, and every kind of crap that comes in. But the thing is that you don't need to mug up anything in mathematics or science. If you're doing that, then failure is guaranteed at some point. So that can't be done. So if you want to think deep and you want to understand what's going on, so first thing to start is with the definition. So definition here, logarithm was nothing new. We have seen that we are familiar with exponential functions, and we have just found another way to express exponential functions. The role of input and output has been exchanged. So writing y is equal to b power x is exactly same as, not this way, because I have interchanged x and y. So where was I writing? So I can quote it here. So writing y is equal to b power x is same as writing x is log y base b. So if I'm not used to working with notation, I will always keep this thing in mind. I will convert this thing into this and figure out what is happening. So this is the most important thing when we start any topic. We have to relate it to something that we already understand. So here logarithms, they are connected with exponentials. So exponentials we are already used to working with. So logarithms must come to us naturally. So that's what I wanted to make it clear at this point. We will be deducing the properties, and we will have better ways to compute this thing. I mean, this is nothing, but this thing is very important. Right, so this finishes off today's work. See you in next one. Bye-bye.